Okay. All right. So let me introduce you before we get started. So I want to thank everybody for coming to our Taos Fall seminar here. This is the first of the semester where we have an external speaker. So I really appreciate folks coming. So I want everyone to join me in welcoming Dr. Julie Demuth. She's just marked 20 years of working at NSF NCAR. So NSF is the National Science Foundation, National Center for Atmospheric Research. So anyone who's in the atmospheric division is very familiar with NSF NCAR, but it's basically a wonderful support organization that helps make sure that we can do incredible atmospheric research. She's a project scientist in the mesoscale and microscale meteorology lab, and she's the lead of the Convergent Science Program, which is a center-wide strategic initiative. She has an interdisciplinary background in both the physical and social sciences, with a BS and an MS in atmospheric science, and a PhD in communication with a focus on risk. She conducts research on hazardous weather risk communication, risk perception, and decision making, including how these intersect with predictability and prediction capabilities. Her love for weather and its effects on people stems from when 7 tornadoes hit Grand Island, Nebraska on June 3rd, 1980, where her family lived at the time. So her talk today is titled Dynamic Weather, Dynamic People, Understanding the Human System to Guide Improved Predictions of Hazardous Weather. So she'll speak for about 40 to 45 minutes. So if anyone has any questions, please do wait until the end of the seminar. And at that point, we'll open up chat as well as audio for questions. But please join me in welcoming Julie to SoMAS.
Oh my goodness, that was just lovely. Thank you so much, Christine. And I just want to say thank you. I feel like I'm talking into a black box here. Thank you so much for this invitation. I'm just really appreciative of it and excited to be the first external speaker of the seminar series this fall. So Christine just nicely characterized the title of my talk here this morning or this afternoon for you. I have many people who I have had the great joy of working with, and I will be acknowledging them as I go along. And unfortunately, since I can't see you, I don't know if people can use the thumbs up if I can see that. I was just trying to hover over here. But I always like to start a little bit with this kind of audience participation. And I'm curious, and maybe you just need to think for yourself, how many of you in the audience have apps or different kind of gear that maybe you use to track your health or your fitness or your sleep? And so for me, I have the Sleep Cycle app. I don't have an Apple Watch. I don't have a CGM. I don't have anything else, but I use that. So I don't know if folks thumbs up if you have something like this.
Lots of thumbs up, Julie.
Okay,
Yeah, lots
good.
of thumbs up. Blue across the screen.
Okay.
Yes. Oh my God,
Wonderful.
so many. They're still coming.
Okay, great. Or maybe you've had, your annual physicals and you get your cholesterol checked. So you have longitudinal data about yourself. And then this is the kind of data that maybe if you have some sort of intervention, maybe you start eating more healthily, maybe you stop, put your iPhone away at night. You can see if there is sort of a positive effect of those behavioral changes on some of these measures. And so that kind of, I always say to try to bring this idea of longitudinal data from people a little bit closer to home, that it's not that foreign. I'm going to talk through it a little bit more as we go along. Christine already did a nice introduction, and clearly I messed up this animation here about my path. But I do feel like it is an important thing to kind of bring into this conversation. We are all very dynamic, and I feel like that's been true about my career path as well. As she mentioned, I am born and raised in Nebraska. There were the Grand Island tornadoes, and this was my iconic event that led me into meteorology. And so this was my track. I just completely poured over these booklets. This is the story. These are the stories I grew up with, even though I couldn't remember it. I was only 2 when it happened. And so this kind of put me on the path toward atmospheric science. I did my undergrad at Nebraska. Then I just charged ahead and went into my master's degree at Colorado State. And there I worked on remote sensing of hurricanes. But it was really while I was there that I started to develop other interests. And so here was one paper in particular that sparked this for me. If you don't know Ann Bostrom, she's amazing. She's now a dear friend of mine. And I, of course, had no idea when I read this in 1999 that she would become this. But Ann had written a paper about people's mental models around climate change. And I read through this, and it might be hard to see for you depending on how big your screen is. But this part I highlighted, I remember back then was so fascinating that these were interviews with people about how they thought climate change occurred, like what were their mental models. And some people thought that spacecraft or space exploration was a cause, that when we launched space shuttles, it poked a hole in the ozone layer and that was contributing to global warming. And of course, that's not accurate, but I remember being so fascinated by the fact that you could study people and how they intersect with weather or climate. And so this is really where, even though I didn't know what my path was going to look like, it was sparked for me. So I went to DC for a while, worked for the National Academies and their Board on Atmospheric Sciences and Climate, met some amazing people, which further supported my path. But I missed the mountains, and so I had to come back to Colorado and was doing work with folks at NCAR. And then this is where they supported me to go back and do a PhD in communication. And like Christine said, I did that while I was working at NCAR, so I just passed my 20 years of being here. And so I'm very grateful for this path. It has led me here. I lead our Weather Risk Analysis and Decision-Making Research Group in the Mesoscale and Microscale Meteorology Lab. Like Christine mentioned, we do work on risk communication, risk perception, and decision-making, but importantly, as it intersects with issues of the predictability and predictive capabilities of hazardous weather events. And these are some visuals of of studies that I'm not going to talk about today, but I'm always happy to dig into this if people are interested. And as she mentioned, I also lead a cross-center initiative here at NCAR called the Convergent Science Program. And if you're not familiar with this idea, kind of at the bottom in the lower right-hand corner there is sort of a one-line version of NSF's definition. It recognizes that we have big, vexing problems, scientific and societal problems that we can't address with just a disciplinary set of expertise, that we really need to bring people from different disciplines, different roles, practitioners, maybe across sectors to bear to tackle some of these problems. And so what we're trying to do in the program is help people understand that, build skills, and then identify some of these big problems that we need to be tackling. I'm not going to talk about this today, but I wanted to really, seed if people are interested in this. I'm happy to talk about it. And then also, I think a lot of what I'm presenting today is an exemplar of the Convergent Science Program. So with that, let me dive into the crux of the research I want to talk about today. So of course we know, and I'm going to put my phone in front of me so I don't go over time, with all of us coming with either weather enthusiasm or weather background, weather and the risk it poses are dynamic, right? We know this. And I'm depicting this kind of in a very simple way in these different rows. You can see the cone of uncertainty is evolving, maybe an atmospheric river event in California with some evolving sort of risks and information that the National Weather Service offices want the public to know. An evolving convective risk from SPC to an MCD to a watch and to a warning. So of course we know this, and we then kind of study the atmosphere accordingly, right? We have tremendous amounts of observational data that we collect with different instruments and different variables. We model things, we model many different parameters. We have multiple models because we know that obs are so critical to first see what's happening, try to understand the processes at play, look at change over time, and then ultimately be able to predict these things. And we do this on an ongoing basis, but then we supplement things at critical times, maybe with dropsondes, or we task 2 satellites to look at so we can get, say, 30-second imagery. So again, this is something that we know is absolutely critical, and I should have gotten my animation going sooner. Well, we also know that people are dynamic, right? We're not static creatures. We grow, we age, we learn, we make new friends or relationships. We have new technology that's changing how we do things. So we recognize that people are dynamic. But if we want to bring these ideas together, here's kind of like this big question that drives so much of the work I'm talking about today. Are people dynamic in response to a dynamic weather risk? And here in particular, a given dynamic weather risk, but we can also think about how weather risks, multiple weather risks over time, okay? So just to unpack this a little bit more, are they dynamic in response to weather risks? And if so, how and when and who is changing? And so you might say, well, why are we wanting to ask these types of questions and develop this knowledge? Well, we do a lot of research in the social sciences, but this is kind of one big gap. And it does minimize our ability to assess the effectiveness of the amazing forecast and warning system that we have in place. So we don't really know how effective that is. We do a lot of stuff retrospectively, but in the moment, collecting this kind of information would really help us better assess how useful our forecast and warning system is, and then improve the development of new tools for forecasting, identify where those improved predictions are most needed. Is it really about different messaging or better types of risk message? Do we need improved skill? If so, of what and when and where? Or do we need to predict different kinds of outputs and give that information to people? And of course, this is all kind of with this more fundamental goal of we're trying to reduce harm that people face from hazardous weather. So what I'm going to talk about today, I'm going to start kind of big picture and go through a couple studies and then really dig in. And the first part is really, as I've characterized it, where the dynamics of people is part of a bigger landscape. And then I'm going to dig into where we're really centering and focusing in on the dynamics of people in response to hazardous weather. And across all of these studies, I'm going to talk about different people, different populations, different types of hazardous weather, different methods, and research that's both fundamental and applied. I also put in some QR codes, so like if you have your phone ready to try to capture some things, but I am also happy to share the slides afterward if that would be helpful for reference purposes. So kind of one first couple of studies that I wanted to talk about where I sort of characterize the dynamics of people as emergent is through some research with National Weather Service forecasters who are operating in their job role. So they are one form of an expert user that we tend to study. And these are a couple of studies where we found that Weather Service forecasters' confidence in their predictions is a very dynamic process. And confidence meaning in terms of what they're forecasting, if they're changing, say, upgrading, or in some cases downgrading a forecast. It, again, is a very dynamic process. And that process is very much influenced by, when they're looking at model guidance, the trends in the model and the recent performance. So they might be looking at consistency over time, if there are monotonic changes in the models, if there's maybe sharpening of an ensemble distribution, if the ensembles of ensembles are showing similar types of things. But then, of course, they're also looking at what the model is forecasting compared with the odds and looking to see, are the models going to catch up? All of those kinds of things are a very dynamic process that forecasters go through, from the order of minutes to hours to days. And these are a couple of papers where that and related ways that forecasters are dynamic have come out. And this, of course, extends to kind of this new hot area of AI and machine learning. And so kind of continuing with this idea based on some recent research we have been doing for the last few years as part of our AI Institute, we found that forecasters, the way that they develop trust in AI or machine learning predictions is very much a deliberative and dynamic process that takes time. And a lot of this work we started about 4 years ago. So I think it's even been interesting to see how forecasters' receptivity to AI has changed over that period of time. But not unlike with NWP, they're constantly wanting to develop familiarity with an AI or machine learning prediction, compare those predictions with their conceptual models of how the atmosphere works. They're looking at performance kind of in the moment over many cases. So they're first getting oriented, then familiar, and then looking at it operationally. But we also found that because of this, again, fundamental goal, in this case for forecasters, of wanting to protect life and property, they're not just immediately like rejecting the idea of AI and machine learning. They're open to it if it helps them do their job. Very much kind of a human AI teaming sort of way of thinking about it, not necessarily automating them out, but helping them in kind of their forecast process. So that's sort of how we have talked about some emergent roles of dynamics. You can also think about how dynamics can be intrinsic. And here I'm drawing on some research I actually did for my PhD of trying to understand people's past weather experiences and how it shaped their perceived risk for future events. And so when you think about that, of course, it assumes change over time or differences over time. And one of the big things that I found kind of looking at the literature, studying people's past experiences, whether it was in the context of hazardous weather or in the context of other types of risk, historically, the way experience was sort of operationalized was very limited, very much like these concrete ways. Did you have damage or were you injured? And those can be really important, but also found that there's other kinds of experiences people have, both direct and indirect. And these emotional experiences can be very powerful. And people can have them, again, if they were directly affected or if they know other people were. And so kind of unpacking this idea a little bit more, found that different types of experiences that people have differently affect their risk perceptions, their beliefs in being able to do something, or what we call efficacy, and the kinds of protective behavioral responses they engage in. The other reason I like to highlight this is because even though we want to do this work to try to understand where we can improve forecast predictions, this is also a really good reminder that people don't just assess risk and make decisions based on that forecast information alone. There's a lot that they're bringing into that context, and their past experiences is a big piece of that. So again, these are just a couple things talking about dynamics in the background. But now I want to talk about how we've done work to center this idea of dynamic weather risk and dynamic people. And we've done this in a couple of ways before I dive into kind of like the main event of the day. So one way we've done this is by kind of studying hypothetical dynamics with different scenarios. And this is a paper that Chris Wers, we just found out like 2 days ago, was accepted into WAF. So this was a study that was funded by the Vortex Southeast program. And what we did was we were looking initially at how people would interpret and use probabilistic tornado warnings, first just statically, but then also if a warning evolved, say, within a 10 or 15 minute time period. And it's a little hard to see. I don't know if I don't know if you can see. If you look in the warning polygon, kind of just to the southeast of kind of the very dark area, you might see a little blue dot. And what we did is we did interviews in person with people who were in the Memphis and Little Rock areas. And we said, okay, that's your hypothetical home location. Here's the first probabilistic tornado warning. Tell us kind of your perceived likelihood of being affected. How are you thinking about it? What are you doing? And with this first warning in this context, we showed them a number of scenarios. It really prompted a lot of people to think they were likely to be hit. They were worried. They said they were going to take action. We're in danger. I would take cover. And then we showed them another visual that depicted the warning propagating. Again, about 10 minutes later, they were in the same location. And here, if you look at that bottom warning, now they're just a little bit south of that darkest red area, but they're actually in the same area, same probability of being hit by a tornado. And here, though, we found that people's perceptions and their responses were that they were really less worried. They thought that the storm was past them. They thought there was relatively less risk of being affected. As this respondent is saying, you're at less of a chance, even though it looks like it's the same chance as the last time. So recognizing, reading the legend and saying, I know it's the same probability, but I think there's a lower probability of being affected. So this is the kind of work that I think we can do more in a hypothetical context when we're wanting to test new types of information. We've also done some work, in this case, it was with a real world event, going into the field afterward and asking people to reconstruct basically the dynamics. What information were they getting? What were they thinking? And what were they doing? So we did this in Georgia in 2017 after a couple of deadly EF3 tornadoes went through the area. One was nocturnal, one was afternoon. They were about 12 hours apart. And we found, even though we talked to people who were in manufactured homes, about half the people were there and about half the people were in more site-built homes or robust homes, so many people were really actively managing their risk. They were attending to information. They installed weather apps. They set their phones to alert them. We had one person who had taken a screen capture of radar. He had the little blue bubble. So he's like, I know I'm here and I know when the radar is propagating toward me and it's this color, it's really bad, even though he doesn't technically understand everything about radar. They decided not to travel. They told their neighbors to get out. They canceled dinner. I mean, all these ways that people are paying attention. And so in this case, it wasn't so much the lack of forecast information or better information that was important. The key barrier we found in this context for this population is that there was no safe place for them to go. And this came up over and over. There's nowhere safe, nowhere to go. I don't know where the shelter is. There ain't no shelter around here. I remember talking to a couple who talked about how they just sat in the closet of their manufactured homes and just like held on to each other as the tornado blew over them, hoping that they would survive. And so again, I bring this up because this is why this kind of work is so important. Again, we always want to improve forecast information. That is central to so much of what we do. But sometimes the solutions are really in other places, like needing to have the ability to provide, maintain, and communicate where safe shelters are. So with that, now I'm going to go into kind of this idea of centering this type of work through longitudinal research or longitudinal studies. And I've given this talk to enough meteorologists to know I have to define this. So the next couple slides kind of unpack what we mean by longitudinal studies. And this is simply data collected at different points in time, okay? And I actually even went in and tried to look a little bit at the etymology of this work. It comes from the Latin word longitudo. I don't really know how to say that. If anybody speaks Latin, you could correct me. But with the idea that this represents length or duration. So of course, it reflects this idea of data collected at different points over time. And there are different kinds of longitudinal studies. One is called a longitudinal trend study, or what we call, it's like a repeated cross-sectional design. And the key features of this is it asks the same questions, but of different people over time. And this lets us look at if there are changes, but more at a population level. And I tried to depict that here with these colors, showing different colors. And so one kind of obvious way you'd be familiar with this is with polling, right? Whether this is political polling or people's perceptions, say, about global warming, where we might see, oh, there's changes in over time in support for this candidate. And we can see that at, again, a population level. But we don't necessarily know who is changing or why they're changing just that there are changes. So that's one kind of longitudinal studies. The kind that I'm going to focus on here is what we call a longitudinal panel study. And this asks the same questions, but of the same people over time. So that makes it more difficult to do. But the benefit of doing this is we can look at individual level changes to see whether, when, and how people are changing and who is changing. And depending on how you construct the study, hopefully what can cause some of those changes. And I tried to depict that here by having the same set of colors at time 1, time 2, and time 3. Once you're oriented to this type of work, you actually see that there are examples of this, even in kind of like our mainstream media. So I captured this on my Washington Post app this past June, a new study that shows social media use predicted future depression in teens. So you probably have heard there's been this kind of longstanding debate. Does using social media cause depression, or is it that people who are depressed use social media more? And what does this mean kind of in the sort of preteen adolescent era? And these people conducted a longitudinal panel study, and found that it was the use of social media that predicted depression in teens. So this is one example of this type of work. It happens a lot in health, public health, a lot of studies around heart disease, all of those kinds of things, a lot in childhood development and how we learn. And it really does have kind of this long history in the study of communication too. This is from back in the 40s, where these folks wanted to see how propaganda affected sort of voter choice. So they conducted a longitudinal panel study. And I think it's interesting that they were looking at this, 60 some years ago, 80 some years ago, excuse me, if I do my math correctly. In the context of hazardous weather, there have been longitudinal studies. But these studies have been done in different ways. So Bob Meyer and his colleagues at Wharton have been kind of at the forefront of this. They were, especially in the kind of the era of the 2010, 2015 timeframe. But they were looking at this kind of in simulated context, where they created a lab and were stepping people through things. Or they did something in near real time for hurricanes. I think it was Irene and Sandy, where they did this trend data, where they phoned people and did these phone surveys as those hurricanes were approaching. But again, they were talking to different people over time. So they could see the population level changes, but not specifically who changed. And then I have colleagues who are looking at panel data for a real world weather context, but they're looking across hazardous weather events, so that they can look at things like, how does your mental health, how is it affected by experiencing multiple hurricanes? Or how do you think about these events as being attributed to climate change? So with this context, let's go back kind of to the big question that I posed before, and I want to nuance it a little bit more. So we're interested in looking at, are people dynamic, again, in response to dynamic weather risks? And then here, for a given real world weather event, while it's threatening. So during that forecast phase where there's a lot of uncertainty about their risk. And again, we want to look at how and when do individuals change, and who is changing, and then also who's not changing. And so this is why we need this longitudinal panel study. Again, asking the same questions of the same people over time. You're going to hear me say that repeatedly. You're going to be so sick of me saying that. But I think it's helpful just to drive that point home. So before I go a little bit further into some of the results, I'm not going to touch too much on theory, but we're drawing on a lot of different theories of risk perception and behavioral responses to risk. And there are a number of things that we're interested in looking at in particular when we do this. I've sort of simplified it here with this graphic. So we look at risk messages or risk information and that come from different sources. So different types of weather forecasts or recommended preparedness and protective actions. We also look a lot at environmental cues and social cues, because we know those are really powerful for people as a type of risk information. We look at risk perception, and this is a giant construct. It can be dimensionalized and measured in different ways, but we look at people's perceived chance of being affected or being exposed, their perceived likelihood of being affected by different negative impacts, how bad those would be, and then sort of like what we call affect, or their sort of like emotional valence, like their negative worry, dread, fear, or even being excited about things. And then different behavioral responses, information seeking and sharing, protective responses, and then also some of the emotional responses. I'm not going to dig into all of this today, but I just wanted you to have kind of a high level picture of the types of things that we look at. And before I get into some of the quantitative work, the sort of first foray that I feel like we had into longitudinal panel data was actually qualitative. What we did was collect, in partnership with many people at the University of Colorado who have expertise in information science, narratives, so full narratives of people, their Twitter narratives, leading up to when Hurricane Sandy was about to make landfall, and while Hurricane Sandy made landfall in the Far Rockaway area of New York. And this was a whole thing. I'd be happy to talk about it. It was really hard to find the people who were in the mandatory evacuation zone, but we ultimately did. And the goal here was to look at their tweets over multiple days and look for indicators of those things that I talked about on the previous slide. And what I'm showing here, this is from one of our papers. It might be a little bit hard to read, but this is one of the Twitter's narratives as Sandy was approaching. And you can see on the left-hand side how I have functionally coded for these types of things. So looking for indicators of there must be some forecast information because she's referencing Hurricane Sandy. And then she says, I fell asleep, I woke up, I can't go back. I'm probably worried about this hurricane as an indicator of risk perception. Social cues talking about when the government is suspending services. We're at some point where she's saying the beach is 1 block away from me, but I'm going to stay home. So deciding that she's not going to evacuate, that's her protective response decision. Environmental cues. And then later on, she says that she's actually at her grandma's house. The good old projects building is going to keep us safe. So clearly she changed where they decided that she was going to shelter and from the storm. So change that protective response behavior and many other things. Okay. And this was really illustrative for us, but it is also, it is somewhat inhibiting because people are sharing what they want to share when they want to share it. We don't have the capability of specifically asking about all of those measures I showed on the previous slide in the ways that we want to. So since we did this Twitter work, we've had in mind that we wanted to be able to do more longitudinal survey data. And that's where I have the good fortune of working with this amazing team of people at NSF NCAR, at Stanford. We've had many other people at CIRA and at the Hurricane Center, but also a lot of NOAA collaborators at OAR, the Office of Oceanic and Atmospheric Research, and National Weather Service, who have been key partners in this process. So we could not do this without this entire team. So here is kind of the research design that we developed, because to our knowledge, this was pretty new. We wanted to collect data repeatedly from the same people over time as an event was threatening, but this required a lot of design to figure out how we would do this. We worked with a lot of survey companies, and there was really ultimately only one who thought that this was feasible to do with us. Excuse me. So what we ultimately designed was that we could field up to 3 surveys during the forecast phase of a weather event. We're going to call these the predictive waves. And then we would field 1 more survey after the event. That would be post-storm. And again, the same people at every wave. This was going to be web-based, English only, and we were using participants from the survey company YouGov. And what we decided we would do is that when there was a forecast event, about 6 days ahead of time, we would make the decision to field. We'd know where was at risk, and then it would take about 24 hours to put the survey in the field. We'd survey people for 24 hours, have a 24-hour interval, another 24-hour survey, another interval, and another 24-hour survey. Again, the same people each time asking the same questions. And if you think about this, it's kind of like a mini, probably relatively much simpler, but still complex mini meteorological field campaign, because there's a lot of things that we had to line up. There were a lot of challenges, predictability limitations, uncertainty. We had issues of cost. Were we going to have people dropping off from survey to survey? Could we get them to respond multiple times? There were a lot of things that we didn't know. When we did this, we kind of figured it was an empirical endeavor, but to our knowledge, nobody has collected this kind of data before. And so we figured we'd try it, we'd learn some things, and we'd figure out how to do it differently the next time. So we first did this in 2020 for Hurricanes Laura and Marco that were simultaneously threatening the Gulf Coast. And you can see here where we fielded. We fielded throughout the entire Gulf Coast area, up to 50 miles inland. And honestly, when we did this, we thought maybe we'd get 20, 30, 40 people to respond. So we were blown away that we had over 1,000 people responding to these surveys. And we did get 3 survey waves in during the predictive phase and a post-storm survey. So we found this to be a big success. And then we got more funds from NOAA to do it again the next year. And we fielded for Henri in 2021 in the areas that you can see depicted there. Again, it was a big success, had over 1,000 people responding to these survey waves. I should note that we let people miss responding if they need to, because you can do analysis with what we call unbalanced data. So we had another great response there. And then we did it again in 2022 for Hurricane Ian. Here we decided to field up to 100 miles inland from the coast to start to look at more of those inland hazards and impacts. And again, had really great response, 3 predictive waves and then 1 post-storm wave. So we were feeling pretty good about this, but also started to see the benefit of collecting these data. And we said, we don't just want to do this for hurricanes. We need to start thinking about other hazards. And so we got additional support from NOAA to field for atmospheric river events. And so we did the first AR event in 2024. It turned out it was leading up to Easter. So we call this the Easter AR. And then we got one more round of funds to do it this past year. And it turned out the event occurred over Valentine's Day. So this is the Valentine's Day AR, not that we're aiming for ARs that occur over holidays here. But it was really interesting to think about how we took the methodology and applied it to a different event, but again, another long fused event. And again, we had a good bit of success with this. So I'm not going to talk about all of this data today. Actually, I'm not going to talk about the AR work at all. I'm going to focus on some hurricane analysis, but I just wanted you to know that we've been extending this to other hazards. And then just a couple more things, and then I'll share some results. I'm keeping track of time. It's not just the survey data that we have that we are using in our analysis, but when people are responding, we know what zip code they're in. We know obviously what day they responded, but we know what time they started and stopped the survey. And so because of that information, we can match each respondent with what forecast products were in effect for their area at the time. So were they in the cone? Were they in a winter watch warning or advisory, and so forth? And we have flags for each one of those products, but this gives us so much power to do even more analysis with our data. So for example, at wave 1, maybe somebody was in the cone, but then by wave 2, they were in the cone and a hurricane watch and maybe a slight ERO. And then by wave 3, they're in all of that, plus a storm surge warning, maybe even a tornado watch. So we can sort of pick and choose which of these different forecast flags we want to use to do some more nuanced analysis. Okay, so now I'm going to dive into some results. I guess I have a couple more method slides, but just to give you a little bit of a sense of what this kind of data can show us. This is from a recent paper, a relatively recent paper that was just published in BAMS that talks a lot about the methodology, but also has some of this empirical analysis to show the value. And these were the two big research questions that we were focusing on. Does the amount of forecast information that people get change over time as the TC is approaching? And does it change based on what of those forecast product areas they're in, what we're calling the predicted exposure to hurricane risks? And then another step, do people's risk perceptions change over time? And does that change based on their forecast area or where they were, their predicted exposure? But also, and this is part of the power of this analysis, do the risk perceptions change based on how much forecast information they've been getting? So this is where we can collect multiple time varying things and do kind of a much more complex analysis with the data. I'm not going to bore you with kind of the longitudinal data analysis, but this is one of the books. This is really kind of our analytical Bible, if you will, that we have been leaning on. And this talks about growth modeling and also something called event occurrence or survival analysis. Here, I'm just going to focus on growth modeling. But what this lets us do is, again, kind of look at individually whether, when, and how people are changing and who is changing. So we can look at stuff with differences within people, but also look at differences between people over time. And what functionally are the two levels of this analysis is at level 1, every individual kind of has a trajectory, right? We know where they start and we know how they change over time. And then what the level 2 analysis lets us do is start to look at between person differences. So to see kind of on average, where are people starting, but then where might people with different characteristics, let's say men versus women start, or people of different ages start. And then we can also kind of extend that to what's the average slope for people, but what does the slope look like for those different characteristics? So that's kind of the quick and dirty version of what we're able to do here. Again, I'm not going to go into it, but I'm happy to answer questions if people have them. So connecting back to those research questions that we're focusing, we have a lot of questions on our survey. And for this analysis, we just picked a few to start to dig in. For that first research question around how much information are people getting and is it changing? We use this one question that's really oriented around different sources. So at every one of those predictive survey waves, we ask people during the last 24 hours, how often did you get information from these different sources? And you can see them listed there: local TV, national news, family, friends, neighbors, and even looking outside of the weather, kind of bringing in that environmental cues. And what we did here is just simply sum how frequently they were getting information across these 8 sources, just for this analysis here. We can do future analysis where we can look at like clusters or individual reliance on different sources. So that's one of the analyses. But then remember, for research question 2, we're looking at people's risk perceptions. And this we have measured in a lot of ways. I'm just picking 4 kind of high level measures here about their perceived likelihood of being affected, of experiencing negative impacts, of those impacts being severe, and their worry. So we do analysis of this, but also with how frequently they were getting information as a potential kind of causal driver of their risk perceptions. And then I think just one more thing before I dive into the results, because again, we don't just have the survey data, but we're able to subset people based on what forecast areas they're in. And for the analysis I'm going to show here, we are breaking people into 3 different groups, okay? We decided to put people in what we're calling the most exposed group if they ever ended up in a storm surge watch or warning or a mandatory evacuation area. So this is technically a time invariant group because those forecast products don't go into effect very often. So for the most part, they only really went into effect at wave 3. So if somebody ended up there, we put them in that category. Then everybody else, their categories are time varying. And we have sort of this middle category that we're characterizing as somewhat exposed. If they're in other tropical products, a tropical storm or hurricane watch or warning, tropical storm force wind speed probabilities more than 30% were in the cone of uncertainty. And then people who ended up not being in any of those areas. And you can see this is an example from Laura and Marco in 2020. Showing how many people were in the most exposed, somewhat exposed, or not exposed areas, and how that changed from wave 1 to wave 2 to wave 3, okay? So with all of this context, now I'm gonna show some of our results here. So remember our first research question, how much information are people getting, and is this changing over time as the hurricane is evolving? And here I'm just showing results for Laura and Marco. Those different colors correspond to those different exposure areas that I just talked about, the most, the somewhat, and the not. On the x-axis here, even though we collected data at 3 waves, we made this a continuous variable of days to landfall so that we could compare across storms. And then on the y-axis is kind of our modeled amount of information that people obtained. And when you look at this, a few things start to come out, right? That the people who are most exposed start off higher and they're getting information at a pretty good rate over time. The people who are somewhat exposed, their rate of change over time is about the same as the most exposed people. They're just starting off lower. And then maybe not surprisingly, the people who aren't exposed are starting off at around a similar amount of information as those other 2 groups, but they're decreasing how much information they're getting over time. And so this is just an example of the output that comes from the model so that we can look at these effects, but then we can also, again, if we want to look at those between person differences, we can do that. We can see that people get more information over time with age, that females get more information over time, and that folks who report being non-white are also getting more information over time if we want to dig into that. And like I said, these results might seem really intuitive, but this is when I draw on my atmospheric science background and the satellite meteorology background and stories that I heard. Of course, I wasn't around during the launch of TIROS-1, but it makes me think about when we first had weather satellites, what we were first able to see, and maybe it validated some things we thought, but also gave us an opportunity to start digging into and seeing more things, or even thinking about additional things that we might measure moving forward. So this is sort of my comparative with the state of, the state of meteorology, kind of where we are now with this analysis. Those results were for Laura and Marco. Now here I'm showing Laura and Marco against Henri and Ian. A couple of things kind of come out here, and I'm going to go ahead and plot this up. So within a given hurricane event, people tend to start getting about the same amount of information across those different exposure areas. But of course, there's different rates and directions of change. And for the most part, the people who are most exposed have the highest rate of change over time. That's not totally true for Laura and Marco. It's the same between the most exposed and the somewhat exposed. But what's interesting is if you look at Henri, the slope is steepest there. And that we're thinking might reflect how people became more aware of the storm as the risk kind of really increased and shifted during the period where we were fielding. I'm going to show some more information about this on the next slide. What's also interesting is that it's only for Laura and Marco that not exposed group actually decreases the amount of information they're getting over time. In Ian, we saw that group was still getting information, increasing amounts of information over time. And that could be just because it was such a big event, threatening a lot of impacts, or based on kind of the orientation of the storm to the coast. These were people who maybe weren't exposed at one point in time, but eventually did become. So maybe they just weren't exposed yet. but knew that they eventually would be. And we can dig into that analysis more in future work if we want to. But digging a little bit into Henri, I think this is interesting in terms of when we choose to field. So when we chose to field, and during the beginning of that first wave, there were no watches that were in effect. Of course, the cone was threatening parts of the kind of New York and the New England area. But halfway through wave one, those watches went up. And also at that point, the forecast was for the tropical cyclone to make landfall as a hurricane. And you all might know this better than I do, but I think at the time it was the first potential landfalling hurricane in this area, I think since like Hurricane Bob in like 30 years. So it got a good bit of media attention. So that might be reflecting kind of that increasing information that we saw over time on the previous slide. But then by the time waves 2 and 3, by the time we fielded them, the warnings were in effect, but the forecast for the storm was to weaken a little bit and make landfall as a tropical storm, which it did. And this then becomes maybe more interesting to our risk perception results, which is what I want to dive into on the next slide. So here I'm just going to show risk perception results for Henri. And again, we're looking to see, excuse me, how do people's risk perceptions change over time based on those exposure areas and also based on how much forecast information they're getting. And you can see before that people can get lots of different amounts of information. So one way we look at this is by creating functionally what we call an envelope, looking at kind of the mean -1 standard deviation of pieces of information that people are getting and the mean +1 standard deviation. And that's the two different plots I have here. And if you look at this, if I can get my voice to work, looking at those two different plots and the two different exposure areas, we can see there aren't any effects of people being in these different kind of the most exposed or the somewhat exposed areas. But there are effects of the amount of information people are getting over time. So really kind of more of what we call an interaction here. And more specifically, people's risk perceptions were increasing over time if they got less information, but they were decreasing over time as they got more information. So now I want to unpack this just a tiny bit more. I said that we took these 4 measures and we put them in an index, but this is a point at which we want to kind of disaggregate and look at this in a little bit more detail. So here on the left-hand side are those 4 different measures for the people who got less information. And then on the right-hand side are those 4 different measures for people who got more. And kind of the punchline here is that as people got more information, they still thought they would be affected, but they were decreasing their belief that they would experience negative impacts, that those impacts would be severe, or that they would worry. Whereas the people who got less information still were increasing their beliefs or their perceived risk of those other factors here. So in the interest of time, I'm actually going to skip over this result and actually just go to one more result that I wanted to talk about. Because one of the powerful things about this analysis, there's been this big vexing question in the field of risk analysis of how risk perceptions and behavioral intentions or responses are actually related to one another. Do your risk perceptions go up and then you engage in some protective behavior and then they go back down? This is sort of a tough thing to unpack, and we're not going to fully get there to unpack that here, but it is interesting to start to learn how people's risk perceptions are shaping their behavioral responses. So one thing I wanted to investigate here, again, drawing on some of those other measures of risk perception, here their perceived chance of being affected by different hazards and their perceived chance of experiencing different negative impacts at wave 2 influenced whether or not they engaged in different behavioral responses at wave 3. And you can see the different responses we measured there. Did they evacuate? Did they make evacuation arrangements? Did they get emergency supplies? Did they gas up? And so forth. And this is just a simple, well, it's a multiple linear regression, so not using the growth modeling or any kind of event occurrence here. And some of the things that we see is that people's perceived likelihood of experiencing strong winds or flooding due to storm surge at wave 2 predicted that they were engaging in more or taking more behavioral responses at wave 3. Also how much they worried about the storm, but then their perceived likelihood of negative impacts, in particular, excuse me, of experiencing power outages or financial losses were the main drivers of whether or not they engaged in different behavioral responses at that later wave. So this was really interesting to see, like what pieces of people's risk perceptions are really driving their behavioral responses. So just to bring us home, so that we can have some time for questions, we have found, kind of answering our big question, that people are dynamic in response to dynamic weather risks. They don't really anchor much to early forecast information. And this was one of the driving questions that motivated a lot of the study, this belief that oh, people aren't, evacuating. They must, even though it's a Cat 3, they must just have heard the earlier forecast and they didn't update their information. But we're finding for the most part that that's not true. We see a lot of variability in how people are changing, different directions, different rates of change. It's affected by their exposure, the storm, demographics, and so much more. That third bullet is the result I didn't show, so I'll skip over that. And we're starting to see some early indications of what are those specific types of perceived risks that are really driving the behavioral responses in a real world context. And we want to look at that across multiple storms here as well and across different hazards. So just to kind of look ahead, and I'm going to pull this up too. We've done this now for 3 hurricanes and 2 AR events. We're about ready to field for, whenever there's another hurricane this season, we are ready to field for another one. And that's telling us so much, but we want to be able to scale this. More of those types of events, but also other kinds of long fused events, winter storms, heat, and then think through how do we do this for rapid onset, spatially localized threats like tornadoes, fires, flash floods, those types of things. There's a lot of ethical issues around that we're grappling with and would love to talk more with folks about. What you saw, we're doing kind of on this every other day cadence, but some of these types of risks are evolving from the weather phenomenon, itself on much finer timescales. So we're exploring, can we collect data from people twice a day on a daily basis so that we can try to capture kind of those finer temporal dynamics a little bit more. And then I think this is kind of where we need to be thinking moving forward. We have so much, increasing amounts of human observational data. How do we think about integrating this with our weather models, with our weather observations, drawing on AI? How do we think about assimilating this either into some of those models? Maybe think about how we can use, again, different machine learning techniques to try to understand the predictability of people in more nuanced ways than we're able to do here. And can we start thinking about predicting impacts in addition to predicting the phenomena and people's responses to that? So this is a huge area that requires a lot of brain power. I'm always open to if people want to brainstorm about this. And then just to kind of bring it back to convergence, I really do think that the team and the different areas of expertise and experiences and roles have been so essential to so much of this. And I love to do a lot of outdoor stuff. And so this is a book I've been drawing on. And I love this quote from the author where he says, the best journeys in life are those that answer questions that at the outset you never thought to ask. And at the outset of my career, or even 10 years ago, I didn't think to ask these questions. And so I really love to think about convergence as like adventures at the edge of our knowledge, where we have to bridge the knowledge from many other people and bring it to bear. So with that, thank you again to Christine and everyone for the invitation, for listening, to NOAA for funding, to YouGov. And I'm going to leave this up and try to minimize the screen so I can see some of you for some maybe 10 minutes of, or fewer than 10 minutes, but some Q&A. So with that, I'll go back. Oh, I can see you.
Okay, thank you, Julie.
Yeah.
So do you, maybe we'll give folks like 30 more seconds if they want to take some QR codes and then maybe stop sharing the screen so you can see us. So I want to welcome questions here. So if folks have questions, please feel free to either unmute yourself or put them in the chat. I'll monitor the chat. I certainly have questions, but I will defer to the audience initially. So does anyone have any questions to kick us off? Yeah, Brian, please.
See if this will work. Hi, Julie. I really enjoyed the presentation, so forth. So yeah, I was intrigued by not only the approach and everything. One thing I was curious about when you showed the information increasing, I was struck how linear it was. So that was one part of the question. And then I'm curious about, what sort of information is increasing, and then I have kind of a trifecta of things here in my mind. But as part of that information, we've done some work here and visualization versus people interaction, and what we kind of found when we were kind of doing some of this is that the interaction among people, as these storms approach, can be just as valuable as the visuals, and so I was curious how that folds into your information and your longitudinal study here.
Oh, yeah. Well, first of all, Brian, it's nice to see you. I actually meant to note in one of those papers, the NWP paper with forecasters, I think we cited some of your work since you have done nice work in this arena too. Okay, let me see if I can The linear, so to speak to that, we model this right now as linear, but we don't have to. There's more complicated analyses that you can do to be either kind of like discontinuous or nonlinear over time, and we just haven't gotten there yet. We're just starting with, the analysis is pretty complex, and so we're simplifying it, so to speak, by showing kind of modeling it as linear. But this is something we want to move into kind of moving forward. I think the idea about what kinds of information, so I just showed how much people were getting information from different sources. And I put those all in one index. We actually have done factor analyses where we can look at how people are getting information, different amounts of information from different subsets of people. And kind of to your last point, even though I didn't show that here, kind of the idea of family, friends, and neighbors, and oh shoot, I don't remember it, but that you do see some of these clusters of kind of how people are getting information from each other as its own cluster and something we could look at, just like the effects of that changing relative to the effects of, say, the forecasters or the news sources. And then the other thing, and this was the result I skipped over, we also measure what channels people are using in addition to what sources, but also what kinds of forecast information are most important to them at that point in time. And so I didn't show that, but that's some other thing that I think we really want to dig into more. Is it that? And so, for instance, one spoiler alert is for Ian, the people who ended up in the storm surge warning, they were really attending to that. They said that the storm surge information was most important to them relative to wind or inland rainfall, which is kind of nice to see those results. But these are also areas where I think there's potential for intervention. If people are attending to certain kinds of information and they really should be attending to others, that we can maybe see that and try to correct that in a moment. I feel like you had three, I know you had three things. I hope I spoke to all of them, but I would love to talk more if you want to.
Yeah, I would enjoy that. Thank you, Julie. Very interesting.
Yeah.
Thanks, Brian. Michael, go ahead.
Hi, Julie. Nice to see you again.
Yeah, you too.
I know, like, just my perception in the severe storms community is that this type of work has been warmly embraced. When I was a postdoc at NSSL, that's when this was just starting to really get its groove. And now, Kenzie's down there doing great work. I was curious what your perception is in the tropical community in terms of working with WFOs that are exposed to tropical cyclones, National Hurricane Center. If you have actionable info, do you think you have a pipeline to have results used in a way that ultimately helps people and changes can be made?
Yeah, those are great questions. And I love that you brought up Kenzie's work. Kenzie's and Joe's, they do these annual surveys of the public, and they measure the same things. That's a beautiful example of the longitudinal trend surveys that I was talking about. So that's a nice complement to these event-based data collection that we're doing. And you're right. I think there has been so much sort of support for this in the severe storms community. I feel like there really has been in the tropical community. We're working really closely with the Hurricane Center on this. We haven't worked as closely with many of the local WFOs. I did give a presentation to, I think it was Lake Charles office after Laura. And to your last point about, so we are seeing support from the Hurricane Center. We were down there this past spring talking with them more about the kinds of data we're collecting and what we're learning, what kinds of things they would want to know so that they can shape some of the questions that we ask. And we're at this point right now with the grant that we're currently funded under, is to see if can we glean kind of with the idea, the analog of meteorology, like we collect these obs, but then we learn things in the moment and then we forecast, right? Or we change our forecast. Can we think about how to operationalize some of what we're learning? It's kind of a big jump. At first, like I said, we were just trying to figure out, can we collect this data? Will it even work? But now we're trying to do kind of near real-time analysis and funnel it to them to say, are these kinds of insights useful? What would be most useful? Is this to you, National Hurricane Center? Does this have to go to your WFOs? Can you use some of this to message with your broadcast partners or with your EM partners? So we're kind of at that point, but it's a huge space. And I think we have a lot to learn, but that is, I would say, the dream. I mean, the dream is like to learn things about human behavior across these different events that represent different kind of predictive capabilities, but also to kind of make this be a little bit more operational, so to speak. and have these interventions to protect people. I mean, we saw some of this with like, and Laura and Marco, because they were both threatening the same area. There were people who were in the cone, for instance, who didn't know they were in the cone. I think it was just kind of, you know, specific to that, and really maybe targeting the people who are in warning areas who don't know that they are. I love this idea though. This is what we want to do. Great, thank you. Thank you.
So we have about a minute. Does anyone have a brief question, perhaps?
Sorry. I talked too long.
Can you hear me? This is Malcolm.
Yeah, Malcolm, go ahead, please.
Just very quickly, I'm interested in the long-term perception of threats as time goes by. And what I'm trying to say is that I was heavily involved in Superstorm Sandy, but that was 13 years ago. And the crisis following that lasted maybe a year in the public perception and the press and so forth. But as time goes by, the fear of it happening again decreases until now. People sort of scoff at me and say, "Oh, Malcolm, that was a freak of nature. It's not going to happen for another 700 years. Just relax and enjoy life." But so how do you counter that slow decline in anxiety?
I love this question. My super quick response is there's a concept in the literature that's more in the hazards community called the atrophy of vigilance. This was more in the context of floods. You know, people would have a home in a floodplain, it'd get wiped out after some period of time, 20 years, they'd forget, they'd rebuild there. And also there's economic drivers there, let's be candid. I think we don't have a good sense. My kind of, you know, response would be that I don't think we know for how much that occurs and for what people. And what I'd love to do is have the longitudinality of longitudinal observations. It's kind of like climatology. We aren't collecting this. If we could collect this kind of data from people all the time, then we could sort of see what their baseline risk perceptions are. And then how does that intersect with a given event? Or how can we see kind of the decline, a curve, and what is sort of the rate of that decline? Is it for certain people, but not for others? Again, it's an observational problem. And so I think it's hard to combat if we don't know how much it's really happening and for whom, other than some really powerful anecdotes. I love it though. It's a great question.
Yeah. All right, well, another round of applause for Julie. Thank you so much, Julie, for coming and visiting us on this Wednesday. Yeah, I am so, the research you do is so cool, and I have immediately downloaded like 4 papers that I didn't already have.
And
So
let's keep the conversation going. If anybody wants to reach out, don't hesitate. I would love to. I love these ideas, and I think it takes a village to do this kind of work that we want to do. So let's do it.
Okay. All right. Well, thank you, folks. Have a good rest of your day. Thanks again, Julie.
Okay, you too. Bye-bye.